The asthenosphere is the highly viscous, mechanically weak and ductilely deforming region of the upper mantle of the Earth. It lies below the lithosphere, at depths between approximately 80 and 200 kilometers below the surface. The Lithosphere-Asthenosphere boundary is usually referred to as LAB. The asthenosphere is generally solid, although some of its regions can be melted. The lower boundary of the asthenosphere is not well defined. The thickness of the asthenosphere depends mainly on the temperature. In some regions the asthenosphere could extend as deep as 700 kilometers. It is considered the source region of mid-ocean ridge basalt. Characteristics: the asthenosphere is a part of the upper mantle just below the lithosphere that is involved in plate tectonic movement and isostatic adjustments. The lithosphere-asthenosphere boundary is conventionally taken at the 1300 degrees Celsius isotherm, above which the mantle behaves in a rigid fashion and below which it behaves in a ductile fashion. Seismic waves pass relatively slowly through the asthenosphere compared to the overlying lithospheric mantle. Thus it has been called the low-velocity zone, although the two are not exactly the same. This decreasing in seismic waves velocity from lithosphere to asthenosphere could be caused by the presence of small percentage of melt in the asthenosphere. The lower boundary of the LVZ lies at a depth of 180 to 220 kilometers, whereas the base of the asthenosphere lies at a depth of about 700 kilometers. This was the observation that originally alerted seismologists to its presence and gave some information about its physical properties. As the speed of seismic waves decreases with decreasing rigidity in the old oceanic mantle, the transition from the lithosphere to the asthenosphere, the so-called lithosphere-asthenosphere boundary, is shallow with a sharp and large velocity drop. At the mid-ocean ridges the LAB rises to within a few kilometers of the ocean floor. The upper part of the asthenosphere is believed to be the zone upon which the great rigid and brittle lithospheric plates of the Earth's crust move about. Due to the temperature and pressure conditions in the asthenosphere, rock becomes ductile, moving at rates of deformation measured in cm over lineal distances, eventually measuring thousands of kilometers. In this way, it flows like a convection current, radiating heat outward from the Earth's interior. Above the asthenosphere, at the same rate of deformation, rock behaves elastically and, being brittle, can break, causing faults. The rigid lithosphere is thought to float or move about on the slowly flowing asthenosphere, creating the movement of tectonic plates. Historical: although its presence was suspected as early as 1926, the worldwide occurrence of the asthenosphere was confirmed by analyses of earthquake waves from the 9.5 MW Great Chilean Earthquake of May 22, 1960. Bibliography: Turcotte, Donald L. Schubert, Gerald. Geodynamics. Cambridge University Press. ISBN 978-0-521-66624-4. Retrieved 24 January 2016. McBride, Neil, Gilmore, Ian. An Introduction to the Solar System. Cambridge University Press. ISBN 978-0-521-54620-1. Retrieved 24 January 2016.